a biconvex lens with two faces of equal radius of curvature r is made of a transparent medium of refractive index mu1. It is kept in contact with a medium of refractive index mu2 as shown in the figure. Find the equivalent focal length of the combination. Obtain the condition when this combination acts as a diverging lens. We can treat this as two lenses, a convex lens of refractive index mu1, another planoconcave lens of material refractive index mu2. The right side is plane, radius of curvature will be infinity. The left side has same curvature as that of the convex lens. The sign convention for convex R1 is positive, R2 is negative. Concave R1 is negative, here R2 is supposed to be positive, but this is infinity. So if you use the combination focal length for two thin lenses with focal length f1 and f2 in air, this is very important. The f1 and f2 focal length are supposed to be in air. f1 focal length of first one in air, f2 focal length of second one in air. When they are placed in contact, the effective focal length of the combination can be calculated as 1 by f equal to 1 by f1 plus 1 by f2. The f1 and f2 are the focal lengths calculated when the lens 1 is placed in air and lens 2 is placed in air. Now we need to find the focal length of the convex part, planoconcave part, then use the formula. So use the lens maker's formula for the convex lens. If it's placed in air, 1 by f1, refractive index of the lens by 1, air or vacuum minus 1. Both surfaces have same curvature. R1 is plus R, R2 is minus R. So minus upon minus become plus. Finally, we get 2 by R. So 2 times of mu1 minus 1 by R. If you go for the planoconcave lens, assuming placed in air, 1 by f2, material is mu2, by assuming air 1 minus 1, 1 by minus R. The curvature of R1 of the concave is same as R2 of the convex. R2 is minus R, R1 is minus R for the concave. The plane surface have radius of curvature infinity. So if you solve it, that will be equal to 1 by f2 will be equal to 1 minus mu2 by R. This minus sign you take inside, be 1 minus mu2 by R. This is not f1, this is f2. 1 by f2. Now finding the effective focal length of the combination. 1 by f equal to 1 by f1 plus f2. Substitute for 1 by f1 from here. 2 times of mu1 minus 1 by R. 1 by f2, 1 minus mu2 by R. When you open the bracket, common denominator, 2 mu1 minus 2, but this is plus 1 here. So minus 2 plus 1 will be minus 1, then minus mu2. So this is the effective focal length reciprocal. You can get the focal length as the reciprocal of the 1 by f. So f is equal to R by 2 times mu1 minus mu2 minus 1. So the first part of the answer is done, equivalent focal length. Now for a lens to act as a diverging lens, the power of the lens or the focal length of the lens has to be negative. So for this focal length or power to be negative, 2 mu1 minus mu2 minus 1 has to be less than 0. That means power or focal length, whatever value you get, has to be less than 0. So 2 mu1 minus mu2 minus mu1 has to be less than 0 because R we already applied the sign convention. Only possibility of the sign has to come from the values of mu1, mu2, 1, this combination. If you add both sides with 1 plus mu2, so 1 plus mu2, or you can transfer to the other side. So 2 mu1 has to be less than mu2 plus 1. Or mu1 will be mu2 plus 1 by 2 if you divide both sides by 2. So if the refractive index of the first medium is refractive index of second medium plus 1 whole divided by 2, then system acts as a diverging lens. Similar to this, you can find even what's the condition for lens to act as a converging lens. That time this both has to be greater than 0. Sign will be greater than 0. This is not equal to, it is less than 0. Now this also, the focal length is not f1, it's f2. Not asked in the question, but for the system to act as a converging lens, for this system to act as a converging lens, power has to be greater than 0. So this will be greater than 0. The whole process will take place same way with the reverse sign. So mu1 has to be greater than mu2 plus 1 by 2.